Welcome to my tutorial called Balancing Equations to the Answers. This is a follow-up tutorial to my earlier tutorial called Balancing Equations. We're going to go through the answers to the questions I set you in the previous tutorial. So for those that are watching this video for the first time and they haven't been able to look at the first tutorial, this is my tally method for balancing equations. So balancing chemical equations using a tally method first requires that you can identify the reactants and the products. And to ensure that you don't get the two confused, you draw a line through the arrow to separate them. So you can see nitrogen plus hydrogen are the reactants to give you the product ammonia. You then do a tally of the number of each type of atom on both sides of the equation. So you can see that on the reactant side I have two nitrogen atoms, because that subscript 2 means that I've got two nitrogens, and I have two hydrogen atoms there. And on the product side you can see that I have one nitrogen there, but because of that subscript 3 it means that I've got three hydrogens. Now there must always be the same number of each type of atom on both sides of the equation. You can add a coefficient, that's a big number at the beginning, to multiply, but you can never add a subscript number. So for instance, you can't add like a little letter, like a little 2 here or a little 3 here. And the reason for that is just give you an example. If you took water, which is H2O, and you added a subscript 2 to that oxygen atom and made it H2O2, that would turn water into bleach, a completely different chemical. So to balance an equation, you only ever add coefficients at the front. So if I then added a 2 in front of ammonia, that 2 would multiply all of the atoms within ammonia. So I would then have 2 nitrogens, but I would have 2 times 3, which is 6 hydrogens. So now my nitrogens are balanced, but my hydrogens aren't. So to get 6 hydrogens over this side, like I've got over here, you would put a 3 in front of hydrogen there. You've now got 2 times 3, which is 6 hydrogens. So now my equation is balanced. Right, okay, my example 2. If I have sodium fluoride here and bromine, they're my two reactants. Then sodium bromide and fluorine are my reactants. You draw a line through the arrow to separate the reactants from the products, and then you complete your tally of the number of each type of atom on both sides of the equation. So again, you have one sodium atom, one fluorine atom, and because of that subscript 2, you have two bromine atoms. On the product side, you have one sodium atom, you have two fluorine atoms, and you have one bromine atom. Now, can you see the order goes sodium, fluorine, bromine on this side, so sodium, fluorine, bromine. Can you see I've kept that consistent on that side, even though it goes sodium, bromine, then fluorine? Well, the reason why I keep my tallies consistent, so sodium, sodium, fluorine, fluorine, bromine, bromine, is when you're balancing an equation and you're looking at these numbers, you don't get confused. If they're directly next to each other, the same element, then you're less likely to confuse them. So there must always be the same number of each type of atom on both sides of the equation. So again, you add your coefficients to multiply. So if I put a 2 in front of sodium bromide, I multiply everything within sodium bromide by 2. So I now have 2 sodium atoms and I have 2 bromine atoms. I've got 2 fluorine. So you can see sodium is not balanced, fluorine is not balanced, but bromine is now balanced. So to balance sodium and fluorine, to make them both 2 like this side, the product side, you can put a 2 in front of sodium fluoride. I now have 2 sodiums and I have 2 fluorines. So now I have 2 sodiums on both sides, 2 fluorines on both sides and 2 bromines on both sides. My equation is now balanced. Right, okay. Example 3 is a little bit more complicated for 2 reasons. Number 1, you've got brackets here, and that little subscript 2 means you multiply everything within those brackets by 2. And the other reason that it's a little bit more difficult is because you've got hydrogen in 2 different compounds on the same side of the equation. So you've got in lead hydroxide here, you have hydrogen, and then you have hydrogen in hydrogen chloride. For that reason, you shouldn't attempt to balance hydrogen first. Pick something different. Do not pick something that appears in more than one compound on the same side of the equation. So again, identify your reactants and your products, draw your line to separate them, and then complete your tally. So you have, on this side, the reactant side, you have 1 lead atom. And because of that 2 outside the brackets, you have 2 oxygens and you have 2 hydrogens. Okay, but as you can see, I've got 3 here. And the reason why I've put 3 here is because you have this additional hydrogen here. So 2 here, 1 here, that's 3 in total. You also have 1 chlorine. So that's my reactants. Now for my products, again, I have 1 lead, I have 1 oxygen, I have 2 hydrogens, but I have 2 chlorines here. So it's not a balanced equation. So again, you're going to have to add a coefficient. So what you do is, again, you don't go hydrogen first because hydrogen, okay, appears in more than one compound on the same side here for reactants. So you could pick maybe chlorine first, for instance. So if I want to balance chlorine, I've got 1 chlorine here, I've got 2 here. So if I put a 2 in front of hydrogen chloride, I'm now going to have 2 chlorines on this side, but I've also changed the number of hydrogens. So I've got 2 chlorines, but because I've got 2 hydrogens now here and 2 here, I've now got 4 hydrogens. So I have 1 lead, 2 oxygens, 1 oxygen, 4 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. So now I put a 2 in front of water. And what that does is it multiplies the number of hydrogens by 2, so 2 times 2 is 4, but it also multiplies the number of oxygens by 2 as well. So I've now got 2 oxygens. So I have 1 lead, I have 2 oxygens, 4 hydrogens, 2 chlorines. My equation is now balanced, okay? So that moves us on to another one, which again is quite similar. You can see that oxygen appears in more than one formula on the same side of the equation, actually on both sides. So you can see here, you've got sodium phosphate, which has got oxygen in. You can see you've got potassium hydroxide, which has got oxygen in. So again, you've got oxygen in 2 different compounds on the same side. And similarly, you have oxygen in sodium hydroxide, and you also have oxygen in potassium phosphate. If you see something like that, don't start with oxygen. Try and pick something that doesn't, an element that doesn't appear in more than one formula on the same side, either side of the equation. So again, identify your reactants and products, draw your line through to separate them, and then you complete your tally. So you can see that you have 3 sodium atoms on this side, you have 1 phosphorus atom, you have 5 oxygens because you've got 4 here and your 5th one here was in potassium hydroxide, you have 1 potassium, and you have 1 hydrogen. And on the product side, you have 1 sodium, you have 1 phosphorus, you have 5 oxygens again because you've got 1 here and you've got 4 here, that's 5 in total. You have 3 potassiums and you have 1 hydrogen. So now you're going to have to add your coefficients. So first of all, I'm going to add a 3 to sodium hydroxide. That means I've now got 3 sodiums, but because of that big 3 there, I've also got 3 times the amount of oxygen here. So 3 oxygens plus the 4 oxygens there, I now have 7 oxygens. And because that's 3, I've now got 3 times as many hydrogens, so I've also got 3 hydrogen. So to balance the other side, okay, we can see that sodium is now balanced, phosphorus is balanced, but oxygen and potassium and hydrogen are no longer balanced, okay? So you can see that if I want to increase the number of potassium to start with, if I put a 3 in front of potassium hydroxide, I've now got 3 potassium, but I've also increased the number of oxygen and hydrogen. So if I've got 3 oxygen here now, because multiplied by 3, plus the 4, that's 7 oxygen in total. And then 3 times the hydrogen means I've also got 3 hydrogen. That means my equation is balanced. So in my last tutorial, I asked you to attempt these, practice these ones and these ones, and then I will be posting another video to provide you with the answers. If you haven't had a chance to attempt these, I would suggest you pause your video. Have a go at them, have a go at both sets, these and these, okay? And then when you're happy that you've balanced the equations, then you can resume the video and green pen mark your answers. So let's look at the first one here. So again, you separate your reactants from your products, you complete your tally. Now, the first thing I would attempt to balance here is the lithium. So if I put a 2 in front of lithium fluoride, I now have 2 lithium, but I also have 2 fluorine. So I can see I've got 1 magnesium on both sides, 2 fluorine now on both sides, 2 lithium on both sides, 1 carbon on both sides, and 3 oxygens. My equation is now balanced. If we look at the second one here, again, you would separate your reactants from your products. You would complete your tally. You would put coefficient 2 in front, okay, and you would see that you now have 4 phosphorus, okay, because 2 times 2 is 4. But you can now see that you've got 2 times 3, which is 6 oxygens. Now, to make sure the other side then balances, okay, you would then need to add another coefficient in front of the oxygen here, okay? So what you would is, because you've got 6 on this side, 2 times 3 would give you 6 on this side. So you've now got 4 phosphorus on both sides, 6 oxygens on both sides, and your equation is now balanced. Again, we look at this one here. Again, you would separate your reactants from your products. You would produce a tally, and you can see immediately that your nitrogens are not balanced, your oxygens are not balanced, and your fluorines aren't balanced. So if you put a 2 at the front there, you can see that you've now got 2 rubidiums, okay, but you've multiplied the number of nitrogens by 2 and the number of oxygens by 2 as well. So that means you've now got 2 rubidiums, but you've got 2 nitrogens, and you now have 6 oxygens. So although your rubidium isn't balanced, your nitrogen is balanced and your oxygen is balanced. So now to balance, okay, your product side. So if you then put a 2 in front of rubidium fluoride, you now have 2 rubidiums, rubidium is balanced, but you also have 2 fluorines. So fluorine is also balanced. So now your equation is balanced. Right, the next one. If you've got silver nitrate and copper, you're going to produce copper nitrate and silver. But to balance that equation, again, you would separate your reactants and products. You would write a tally out for all the different atoms. And if you put a 2 in front of silver nitrate, you can now see that you have 2 silver atoms, you have 2 nitrogens, but 2 times 3 is 6, So you have 6 oxygens and you've still got 1 copper. So to balance this equation, to get twice as many silver, you would put a 2 in front of the silver. And then your equation, okay, is balanced. Right, next one. Separate the reactants and products. Again, provide a tally. If you put a 2 in front of bromine there, you can see now you've got 2 times 2, which is 4. And then if you put a 2 in front of fluorine here, you can see now you've got 2 times 2, which is 4. And fluorine is also balanced. So you can see that you've got 1 carbon on both sides, 4 fluorines on both sides, and 4 bromines on both sides. Your equation is now balanced. So, next one. Again, same idea. Right, okay, for the next example then, okay, separate your reactants and your products. Do your tally of the atoms of each element. And then you can see that the first one that you perhaps might attempt to balance, okay, is the number of hydrogens and carbons. So you can see that you have got 1 hydrogen here, 2 here, you've got 1 carbon here, you've got 2 carbons here. That's resolved by putting and 1 nitrogen there, 2 nitrogens there. That's resolved by putting a coefficient 2. So now you can see your equation is balanced. Right, next example. Okay, again, separate your reactants from your products. Do your tally. You can see that you've got 1 gallium, okay, but you've got 3 fluorines on this side, only 1 on that side. So putting a coefficient 3 in front of cesium fluoride means that you've now got 3 cesiums, but 3 fluorines. Now, to ensure that you've got an equal number of cesium atoms on the reactant side, you put the coefficient 3 in front of cesium, and now your equation is balanced. Okay, next one. So for this one, again, separate your reactants from your products. Do your tally for each of the elements. And you can see that that one is already balanced. So you don't have to do anything with that one at all. Next one. Separate your reactants from your products to complete your tally. And you can see for this one, fluorine isn't balanced, lithium isn't balanced, but the rest of them, magnesium, carbon, and oxygen, they're balanced. So to double the amount of lithium over here, you could put 2 in front of lithium fluoride. That gives you now 2 lithiums on this side, but also 2 fluorines. Now your equation is balanced. Next one. So again, separate your reactants from your products. You have balanced carbons, but you've got twice as many hydrogens here, and you have more oxygens on this side. So again, don't attempt to balance the oxygens, because as you can see in this particular example, oxygen appears in both formula, the carbon dioxide and the water, on the same side of the equation. So deal with the hydrogens first. So if you want to turn hydrogen into 4, then you could put 2 in front of water. You've now got 2 times 2, which is 4 hydrogens. And you've now got 2 times the 1 oxygens here, which is 2, plus the 2 there, you've got 4. And to make sure that you've got 4 oxygens on this side, you can put a 2 in front of the 2O2. You've now got 2 times 2, which is 4 oxygens on that side, and your equation is now balanced. Right, reactants and products again. You have sodium phosphate on this side, you've got calcium chloride, you've got sodium chloride, and you've got calcium phosphate. Again, separate your reactants from your products, complete your tally, and you can see, okay, looking at this one, that you have 3 calcium on this side and only 1 on that side. So to increase your number of calciums by 3, you could put the coefficient 3 in front of calcium chloride. That would mean that the number of calciums increased to 3, but that would mean that your chlorines increased to 2 times 3, which is 6. So you've got 6 chlorines. Now, to increase your number of chlorines to 6 on that side, you would put 6 in front of sodium chloride. That means you now have 6 chlorines on that side. But that also means that you have 6 sodiums on that side. So to balance your number of sodiums, you would put coefficient 2 in front of sodium phosphate. 2 times 3 for the sodiums would be 6, but now that doubles the number of phosphorus from 1 to 2 and the number of oxygens from 4 to 8. Now your equation is balanced because you have 6 sodiums on both sides, you have 2 phosphorus on both sides, you have 8 oxygens on both sides, 3 calciums on both sides, and 6 chlorines on both sides. Okay, so the next one then. So potassium plus chlorine gives you potassium chloride. Again, separate your reactants from your products, complete your tally. Now to make sure that the number of chlorines balance on both sides, you could put a 2, coefficient 2 in front of potassium chloride. That increases the number of chlorines to 2, but also increases the number of potassium to 2 as well. So to ensure that your potassium is balanced on both sides, you can add the coefficient 2 in front of potassium over here, and now you have 2 potassiums on this side too. So, right, okay, so our next one here, so aluminium plus hydrogen chloride gives you hydrogen gas plus aluminium chloride. So again, separate your reactants from your products, complete your tally. And you can see that immediately your aluminiums are balanced, but your hydrogen and your chlorine are not balanced. So what you could do, okay, to balance them is you could, okay, put a 2 in front of aluminium chloride. Now the reason why I would say put a 2 in front of aluminium chloride is because you've got 1 chlorine here and you've got 3 there. And what I'd be ideally looking at is what would go into 6 to balance those out. So if you had 2 times chlorine here, you would have 6 chlorines. So you could then multiply that by 6 to balance it. So you can see you've got 6 chlorines there, but you've got 2 aluminiums. By doing that, you have 6 chlorines here with a coefficient 6, but you will have 6 hydrogens now as well. So to balance the number of hydrogens on this side, you can put a 3, okay, in front of the hydrogen, and then you have 6 hydrogens on that side as well. So that means that you've got a balanced equation. Right, so our next example, okay, nitrogen plus fluorine gives you nitrogen fluoride. You can see that you have 2 nitrogens on that side, you've got 2 fluorines on that side, you've got 1 nitrogen on this side, you've got 3 fluorines on this side. So to balance this one, you could put the coefficient 2 in front of nitrogen fluoride. You would then have 6 fluorines and 2 nitrogens. And to balance the fluorines on that side, because nitrogen's already balanced now, you would put 3 in front of fluorine. And then 2 times 3 is 6. So your equation is now balanced. For this example, okay, where you've got sulfur dioxide, okay, at the beginning there, you would, again, draw your tally out for the particular reaction, looking at how many atoms of each you have on both sides. You would draw your line to separate your reactants and products. You could put 2 coefficient 2 in there, which will double the number of selenium, but also double the number of lithiums. So you can see that you now have 4 lithiums on this side, okay? Now, to balance this side, you would put a 2 in front of lithium oxide. So you now have 4 lithiums on that side. You have 2 oxygens, and your equation is now balanced. So next one, okay. So again, separate your reactants from your products. And you can see if you look at ammonia and sulfuric acid there, you can see that the number of atoms of each element is as follows, and the same for ammonium sulfate on this side. Now, what you can do is you can put a 2 in front of ammonia. That doubles the number of nitrogens to 2, but the number of hydrogens now, okay, is going to increase quite a lot. And the reason why that increases quite a lot is because you've got 2 times 3 there, which is 6, plus your 2 there, which is 8. Okay, so 2 times 3 is 6, plus a 2 there, which is 8. Okay, and then in doing that, your equation is then balanced. So I'm hoping that you did have a go at doing those in advance of the tutorial and that you got 100% on those balanced equations. And if you didn't, then go back and have a look at the original tutorials to make sure that you understand where you might have gone wrong. Feel free to send me any requests, or if you've got any questions, please drop me a comment. Thank you.